So we've talked about the general rule for logs, and we've talked about product rule, quotient rule, and power rule for logs. The last thing we want to talk about is the change of base formula for logarithms, which tells us that when we have log base a of b, that's going to be equal to log base c of b divided by log base c of a. So you'll notice that the argument of the logarithm becomes the argument for the log in the numerator here. The base of the logarithm becomes the argument in the denominator, and we change the base of both these logs to c, and we can pick whichever value we want for c, but the value we usually pick is 10. And the reason is because we want to change this logarithm, log base a of b, into two logs with base 10, or the common logarithm. And that's because oftentimes when we're dealing with logs, we're going to use our calculator to estimate the value of a log. And when we use the calculator, we want to be able to use the log button, which is automatically log base 10, or the natural log button, which is automatically log base e. So when we don't have base 10 or base e, we want to be able to change this into the common logarithm. And so a simple example would be if we had something like log base 5 of 4. So in this case, we don't have base 10, we don't have base e, but we can use the change of base formula to turn this into two base 10 logs. So we know, based on the change of base formula, that this is equal to log base, and we'll pick log base 10, so log base 10 of the argument 4 divided by the same log base 10 of the base 5. And so now we have two common logs. We could also drop the base 10, and we could just write this as log of 4 over log of 5. This is the same value, or has the same value, as log base 5 of 4. Now we can easily punch into our calculator what's log 4 divided by log 5, and we can see that the value of that is approximately 0.8614. And just like with all of the log rules we've talked about before, we can use this change of base formula in combination with any of the other log formulas if that's helpful to us. So if we need to use the change of base formula along with the power rule for logs, along with the general log rule in the same problem, whichever rules help us to simplify, we can use those. We can also, like the other log rules, start with this value on the left, like we did here, and move to the value on the right side of the change of base formula, or we can start with a value on the right side and move to the left. So for instance, we might be given something like, let's say, log of 81 divided by log of 3. We know that that's the same as log base 10 of 81 divided by log base 10 of 3. The fact that we haven't written the base 10, it just tells us that this is the common log, which has base 10. And so we see that this matches up with the right-hand side of the change of base formula. So we can use the change of base formula in reverse to convert to the left-hand side here. And we see that we get log base a, well, that comes from the argument from the denominator, so log base 3, of b, the argument, that comes from the argument of the log in the numerator, which is 81. So we get log base 3, and let's actually move this down a touch. We get log base 3 of 81, and now if we want to find a real number answer for the value of this, log base 3 of 81, we can use the general log rule to convert this into exponential form. We know that that's the same as 3 to the x equals 81. 81 we know is the same as 3 to the 4th power. So we could say 3 to the x is equal to 3 to the 4. And then because the bases are equal, we know the exponents have to be equal. So we get x is equal to 4. So what we've shown then is that the original value we started with, that has a value of 4, which we found using the change of base formula in combination with the general rule for logs.